Welcome to qnawire.
This question, we have a piston pushing a bar down. That's point A. Point B is down here. So point A is up on the left. Point B is down on the lower right. And it's pushing this bar along a roller, along a circular bowl here. So what we can do first is find this angle beta. And we can just look at the sine of beta. Is the opposite side of the hypotenuse. That's r over 2 divided by 1.25. And we can take the inverse sine of that. So I'll call point C the bottom left here. So we take the length of CB, divide that by the hypotenuse, which is BO, and we get an angle of about 23.6 degrees. So next, we can write down VB, a formula for the velocity B, such as VB times the cosine of this angle in the I hat direction plus the sine of this angle in the j hat direction. We also know that the angular velocity will be in the k hat direction, so we'll need that going forward here. We know that the velocity of A is only in the negative A direction, so that's just the magnitude of velocity of A in the negative j hat direction. So that's fairly simple for us to write down here. We then want to write that the position of B with respect to A is just going to be the length of that rod AB, which is R, times the sine of the angle, which was 30 degrees, which I forgot to write here, but that is a given in this problem, in the I hat direction, minus cosine of 30 degrees in the j hat direction. We then want to find the velocity of B with respect to A, and we can do that looking at omega crossed with our r of B with respect to A. And this will become omega times RB with a few changes to the I hats and j hats so that they're in the correct directions here. But this leaves us with and that all comes from k hat cross I hat, and giving you a j hat, and k hat cross j hat, giving you a negative I hat. So this will give us an omega times 0.346 in the I hat direction plus a 0.2 j hat omega. So next thing we can do is write the velocity of B as simply the velocity of A plus the velocity of B with respect to A. And this will give us a 0.346 omega I hat plus a negative 0.8 plus 0.2 omega j hat. And we can set this equal to our VB above, which I'll star here and down here, and we can compare just the I hat portions and just the j hat portions. So first the I hat portions, we have VB times the cosine of VB, and that cosine gave us a 0.916, and this equals then just the I hat portions in the omega formula, so that's the 0.346 omega. We have a similar equation for the j hat portion, so that's VB times the sine of beta, which should give us a 0.4, and that has to equal our negative 0.8 plus 0.2 omega from the j hat portion. So we can divide these two equations to solve for both omega and VB. So first, when we divide the equations, we solve for omega. Immediately on the left side, the VB's cancel out, and then we have a little bit more algebra to solve for the omegas, where we find that the omega is 16.4 radians per second in the counterclockwise direction. We then look at our equation on the left here and realize we can use that to find VB fairly quickly. So VB would be 0.346 divided by 0.916 times omega. And when we put these numbers in, we get about 6.2 meters per second.